Hello guys, today I wanted to give hello guys, today I wanted to show you some important two-dimensional projectile motion. Okay, two-dimensional 2D projectile motion. I'll show you the derivation. Okay, how can we calculate derivate the projectile motions formula? Okay, now given, okay, this is, assume this is a horizontal surface. Okay, and you throw the ball at an angle theta. For example, this is a green color ball, this is a ball. Now assume that this ball is projected. Okay, projected, okay, like this one, okay, like this one, okay. And it's moving along this trajectory. This is a trajectory, what you call the path of the free moving ball which is thrown. So how can we derive the formula to calculate the displacement of the particle or physical body such as a ball which is thrown? What is the, at what time does it reach within the some distance y from this position, for example, at what, at time t? Okay, what is the position of the particle? Okay, let us see how can we solve this. We know that from kinematics, okay, one of the branch of, okay, mechanics, mechanics can be divided as the dynamics and kinematics. Kinematics studies about the motion of the physical body. Okay, now from kinematics we know that displacement is given by initial velocity times t plus half of at square for uniform acceleration for uniform acceleration. Uniform means constant. Okay, uniform means constant, that is constant acceleration. Now once we know this formula, okay, the displacement is equal to ut plus half of at square, and the acceleration is uniform acceleration. Uniform acceleration means constant, so we do have initial velocity, time, and acceleration as a physical parameter to determine the displacement of physical body which is thrown freely through the air under the control of gravitational force. Okay, now the other velocity formula, v is equals to ut u plus at. Okay, which means the u is initial velocity, it is initial, u is initial velocity, v is the final velocity, what you call it, initial velocity. In our case, v is final velocity. Okay, so the final velocity is equal to the initial velocity plus at. So we have seen two important relations. One, as displacement is given by ut plus half of at square, and v is given by u plus what, 80. The two relations are formulas are very important to determine the displacement of a particle or a physical body when it's thrown in the air, only controlled by the gravitational field of the earth. Okay, so how can we change this one? Now when you throw the ball, for example, from this to the air, okay, it follows this type of trajectory with, as I have said, with initial velocity u. Okay, so there is, okay, if you assume this is a Cartesian coordinate system, x and y Cartesian coordinate system, then what you have here, we do have at this trajectory, we do have always x and y function, okay, basically, and also in addition time. So displacement or a movement has a function of velocity and time. So at these positions, at x and y coordinates, so we may define this point. Okay, we should define this point. So this particle at this position, the particle at this position has y coordinate as well as x coordinate. When it's reached at this point, it has also x coordinate as well as y coordinate. Okay, and it has a velocity v at this position, okay, before it strikes the body and come to at rest. So instead of s is equal to u t plus half of 80 square, okay, here plus, there is plus here, we can write, instead of, we do have y displacement, vertical displacement y is equals to what? Uy, our component, because we can resolve initial velocity into ux and uy component. Okay, so t, it is t, same, plus, instead of a, acceleration a, we can substitute by minus g, because it is gravitational acceleration, half gt square. Okay, so y is equal to uyt minus half gt square. Okay, the other is what you should know. What about the velocity? As I have said, that there is a component of velocity here when the ball is thrown like this one, as we have said, when it's moved like this one, at any point we have, where, for example, at this point v is as a function of x and y. Okay, so v y for the vertical component is equal to initial uy minus gt minus gt. Okay, but for horizontal component, ax is equal to 0, so vx is equals to ux. Okay, ux, because x is what is equals to 0. Other thing is what? U, as we have said, ux is can be decomposed into u cos theta and uy u sin theta. Okay, let me summarize again. In short, we have said that y is equals to uyt minus half gt square. Okay, this is for example 1, and the other is Vy is given by Uy minus gt. Okay, this is 2, and the Vx is given by Ux. Okay, this is 2, 3, and Ux is given by U cos theta, and Uy is equals to U sin theta. Okay, this is 4. Okay. Now, once we have written this one and shown this one, we can proceed by substituting the value y again given by, instead of uy, we can write u sin theta from, from 4, as I've shown you, minus half gt square. Okay, this is 5. 5. And x is what? X is given by uxt. Okay, so which means u cos theta times t. This is 6. So t is equals to from this one, t is equals to x over u cos theta is also 7. So let us substitute to the this value here. Let us substitute this value into this value. Okay, substitute. So what will happen when you substitute this one? Y is equals to u sin theta, okay, x over u cos theta minus half g x square u square cos square theta. So what will happen? Y is equals to tan theta times x minus half of g into x over u cos theta. Okay, this is, let us square this one. Okay, this is a very important general formula which helps us to determine, okay, the position of the physical body at any x position. Given x, so given x position, so you can find y. Okay, you can find y by this formula. So if the angle is known, if the angle is, this angle is known, theta is known, or phi, and x is known, g is known, so we can determine the position of y at any x position. So like a quadratic equation or a linear function, we do like this one. Okay, so in general, when you say this function, rearranging this function, y is equals to tan theta x, okay, minus half g over u square cos square theta x square. Now if you seriously look this value, okay, this value, you know, this can be substituted as a x, okay, minus what, or bx square, like that type. Okay, I can make like plus, for example, here. So you can change this to the negative, plus minus, okay, minus b x square. This is a parabola equation, you know, parabola, okay, parabola function. So a projectile is a parabolic function. It is a parabola or a parabolic function. Now let us determine hmax. Determine maximum at hmax. How can we determine hmax? Okay, hmax means when a body is projected from the horizontal, from your horizontal level as you, to the air, as we, okay, we have component what, y, y and ux, okay, when it travels through the air like this one, it will travel to some maximum distance here, what you call it hmax. The other is the range. Range means also from this point to this point, okay, range the maximum horizontal displacement, and hmax is the maximum vertical displacement. So how can we calculate this one? Okay, to do so, hmax, to get hmax, we know that Vy will be 0 at hmax because it is a turning point. We have only x component. We have only x component here. Here we have only Vy is 0 at this point. We have only u Vx. Yeah, Vx. We have only Vx, no V1. Vx is different from 0, that Vy is equals to 0. So it makes things easy. So instead of, we know that Vy is equals to Uy minus gt. So this will be what? This will be cancelled because it is 0. So Uy is equals to gt. So rearranging this one, times gt is equals to Uy. Okay. Then t is equals to what? Uy over g. Uy over g. Okay. Uy over g. So we have time, which is Uy initial velocity onto the vertical component divided by g, the gravitational acceleration g. Okay. So what we are going to do is that we can substitute this value, okay, from y value. Instead of y is equal to, we know y is equal to Uy t minus half gt square. Okay, instead of y, hmax is equals to, instead of t, we can substitute Uy, uh, Uy over g, okay, minus g, okay, times what? Uy square over g square. So here it's clear that we can cancel g by 2. Okay, Uy square. So hmax, just to clear here, let me do Uy square over g minus Uy square over, here is half, yeah, 2, okay, 2g. here to G. Okay, so we know that hmax is given by ui square over G minus half of ui square over G. So ui square is common, ui square over G, 1 minus half. Okay, 2, which is equivalent to say ui square over G. So hmax we can substitute here. We know ui is what? Ui means u sine of theta. Okay. Ui is equal to u sine of theta, and hmax is equals to ui square over G. Okay. 2 times G. Okay. Because 1 minus half is half, so this will be given us u square sine square theta over 2G. So hmax is given by u square sine square theta over 2G. This is the most important derivation uh, for two-dimensional projectile motion. Okay. The other is range. As I have said, range is a maximum horizontal displacement. So range, what you call it, x maximum. So which is equals to ux, okay, times t plus half of x t square, but we know that this value is 0, so simply we can write, okay, ux, to clarify, let us total time total time t total, okay, t total. So range is given by ux times t total. What does it mean? Total. We know that in previous. Okay. Previous t is given by what? T is given by simply ui over g. Okay. For we have seen vy is equals to what? Ui minus gt, but at maximum height this is tended to what? 0. So from that we say that t is equals to ui over g, but here don't remember t total is equal to 2 times of t, okay, t times of t. So instead of t is equals to ui over ui over g, but t total is equals to t, so that range is equals to ux times t total means 2 t total, which is equal to ux times 2 times uy over g. Okay. So that we can get range is given by 2 times ux uy over g. So to determine the range, only the initial velocity is okay enough, okay, or sufficient. So we can R is given by 2 times of u cos theta, okay, u sin theta divided by g, okay. So what's R? R is again given by 2 times of u square cos theta sin theta divided by g. But we know that from trigonometric relation, from trigonometric relations, um, sine of theta, alpha plus beta. If you remember, it is sine of alpha cos of beta plus cos of alpha plus sine of beta. So if you substitute by instead of sine of theta plus theta, which is equals to what? Sine of theta cos theta plus cos theta sin theta. Okay? Which is equivalent to say sine of theta is given by 2 times of cos theta sin theta. So if you write that range, then the range is given by what? The range is given by, so in substitute to that value range is given by u square sine of, okay, 2 theta over g. Okay. Now this is also the most important formula for two-dimensional projectile motion. Okay, to summarize the point, three formulae has derived. Okay, here one general formula for any position for the y, one formula we have y is equals to what? Tan of x minus half 2g u square cos square theta x square. Or let me clear it. Y is equals to tan tan theta, okay, tan theta x minus half of g, okay, x square over u square cos square u square cos square theta. The other is the hmax, which is given by u square sine square theta over 2g. The other is range, which is given by u square sine theta sine 2 theta, okay, 2 theta sine 2 theta over g. Okay, I think this video can illustrate and give clarification for your uh, projectile motion concept. Now study this video. I will proceed